So hey everyone, in this video we are going to create this Apple kind of website landing page in which there is a 3D kind of thing that's running out of it. No, it's not a 3D model. No, it's not a video that's basically running on scroll. It's something completely different. So let's jump right into it. So the first instance that you get is it a 3D model that is loaded into 3JS? No, it's not, because if you just have a clear mindset, every mobile device or every device doesn't support 3D rendering. If it does support, let's say it would be laggy, because in Safari it's laggy. The 3JS doesn't work well. It works well in my case only with Chromium based browsers. Next is it a video? But if you see, if that's let's say 1080k video, or even a small video, if you are rendering under a video tag, it needs some times to load. So that's also a bad strategy. It's good in some cases, they both are good, but in this type of cases, the Apple has done a really commendable job. Basically, on just inspecting some here a bit, they are actually using images on scrolling. They are just getting the fraction of how much area has been scrolled, and based on that fraction, using the unitary method, if I have, let's say, 42 frames in total, then only one frame, and according to the height of that. Okay, let me just give you a quick math. So basically, if uh let's say we have 42 frames in total, okay, and we are at one, so it will check if it's X frame, how many going to be that. And the next is, if we have scrolled a certain fraction, and based on that, how much, if I have, let's say, 500 VH of height, and how much fraction of height has been scrolled, and based on that, the X value is calculated on which frame we are. So that's how we calculate our this thing, in how much we have scrolled and which frame are we on. So basically, if you go into the inspect and refresh, it's, as you can see, we are rendering out all the frames one by one. So basically, this helps us in lazy loading the first. So first is loaded, then we are actually lazy loading it. And if you see, it is only around 100 KB, till 100 KB. We can also optimize it further, but you get the point. And if you say how we are getting those images, so basically you can write a dead simple code in whatever language you want, which basically converts, let's say a video has a 60 frames per second, right? 60 FPS, and it spans across 10 seconds. So what you can basically do is you can write a script in which you can convert, and per second it selects, let's say, 10 FPS with a gap. Let's say it first selected the first frame, then it selected the 10th frame, then it selected the 30th frame, something like that. And then you can basically render that. You don't have to render the whole context, because even if you see here, it's only 63 frames. But in actual video, it must be around more than that, like probably more than that, because you can see it's so in human eye, we can't see on scrolling because we are doing that. But in video, you might notice a subtle difference, but here you don't notice that. All right, so that about the background. Now let's jump right in the coding. So let's create a new project, which is Apple landing page. In here, the first thing we need to do is do npm init, because we are basically using the Vite engine. Although we don't need it, we are not installing any. And then going to the package.json, and the first thing would be to do dev Vite, and then the build, which is going to be just Vite build, and then create a new index.html file. So now let me make it a little bigger. So the first thing we need to do, if you don't know, we are basically using Canvas. This whole Exila draw is, I think, based on Canvas, if I'm not wrong. Let's just quickly check it. So as you can see, it's basically based on Canvas. So Canvas is pretty powerful API. If you learn that, that's really cool. You can create various sorts of things, which is pretty optimized. Now, let's go over here and we will create a canvas. So the first thing we need to get is the canvas. So document.get element, document.query selector. I basically like this one because it gives this thing, which is the completion of this. Now this is probably going to be, let's just run npm on dev, open up this thing, go into here. Okay, so in the HTML, we'll probably add a particular height, okay, which is going to be 500 VH, which basically means we have this whole canvas. So whenever you are doing this type of scroll things, you need to predefine the height because you are scrolling based on the maximum height that is available to you. Now you can do it in different ways. So the first approach would be so let me just give you a simple approach. If you want to do it, let's say I have to do something and then I have to make it as a normal page scrolls. So what you can do is put an element inside element and then do that overflow X. So whenever that element is scrolled and then after that scrolling has been done, it would automatically it would automatically propagate to its parent element and then it would scroll. So that's a quick fix. If you don't understand, let me know. We have the full height because I just wanted to do this. This is the exact thing that I was looking for, which is the black background. Now the canvas is probably going to be position fixed, left this, right this, because if we don't do this, let me, just make it hidden. Open the dev tools. There you go. We have the canvas. Where's the canvas? In the body. And there you go. There is the canvas. Now, if we go up, the canvas is up. Now, if you can clearly see here, we have the canvas sticked right on top of our screen. So it's scrolling, but the canvas element is not going. So we need to do this, which basically you can actually, I actually memorized this piece of code, which is left with right 50. For any position absolute or any position fix, if you want to make it center, you just have to do this. It's pretty damn, it works really amazing. So I basically memorize all those things to make my code faster. All right, now let's jump right into the script tag. So first thing we'll do window.onload. We are we are creating a new application when window is loaded. Then what we basically do is we'll set the canvas width to the width that we are getting over here, then the canvas height to the inner height, and then the background should be transparent because I don't want to do any sort of stuff that breaks or makes the thing. Basically, we want to also show that Apple pods over there. All right. Now, if you don't want to watch any of this, you can directly go to my GitHub. Okay, that's just me explaining over here, and I don't consider myself too good at explaining things. Okay. Now we'll create an images and the loaded images is going to be how much images that has been loaded from the cloud. Now we are going to be using the official Apple thing to load the images. So that basically means if you go to Apple AirPods Pro website, and if you see here, that's the exact that we have been creating. Now this is actually also an image. If you can't select this thing because it's in the canvas, but this is also an image. Now we are basically going to do the exact same thing. So what we are doing over here is we are getting the total images. So total images that has been provided by Apple. How I do it in inspect element, and you can basically get the total images and you can get the current frames. So the current frame index is going to be the one which is the first index. Now we are iterating over the total images because we know how we know that we have 64 because we have rendered it. How we have rendered it is using the xcalidraw function. Whatever that I explained in the xcalidraw, that how we are getting the function is by divided that into this thing. So in your cloud how much or how is the quantity or how many frames that you have rendered through your program, so you know that pretty well. Okay, now let's go deep now. So we are getting all the images that is required. Oops, that is required by the things. So image.source is going to be the actual Apple source, which is iPads Pro. Now how I get this URL, basically inspect element. Okay, every secret of web technology front end lies in the inspect element. Now now if you can see here, I have done string.pad start 400. This basically means, if you don't know about this pad start basically means I have to start from 0 0 0 0 and 1. Why I have done this? Because Apple doesn't have such as if I show over here, if my URL is slash medium, it doesn't have like 1.png. It is like 0001.png, then 002.png, then it's 52.png, then 62.png, something like that. So they have an additional zero. So I've done a quick Java. Now you can do this in vanilla as well by using 000, but you have to, mention or do also for if the image or is if the index is 2 digit and all those things. So pat start gives you a pretty good code thing. Now let's go back. Now I'm going to just push the image, but I want to call a render function, which basically, where is my brave? Okay, which basically have the control over here to draw, but I don't want to draw I only want to draw after all the images has been loaded successfully. So what I'll do now is basically have an image onload function, and then I will append the loaded images, which has to be equal to the total images. So if loaded images is equal to the total images, we are basically adding an event listener, which is the scroll listener, and we are calling a render function. Now, if we save here, we'll basically get this is what event listener is not there. So now let us create an add event listener and a render function, right? And in render function, we are basically going to request animation function this dot render dot bind this. Okay, actually we don't need this because we are triggering that. I would have been use a request animation frame when it was a continuous event. Now in the add event listener, we are basically going to add a listener to scroll because obviously we are scrolling. That's why that's when we are triggering the event. And then on scroll, what we are doing is how much we have scrolled. Okay, which means if I am on the top, then the scroll top would be 0. Max scroll would be the scroll height and minus the inner height. So the scroll height is actually defined by the 500 vs that has been already defined, and the inner height is basically the 100 vs. So it's 400 vh. So that's maximum that we can scroll. Now we have the scroll fraction. So how much we have scrolled and what's the max scroll top. So based on that, we are basically calculating a fraction. So if it's 500 VH and if we are halfway through, then it's going to be 250 VH. So now if we are at the 250 VH, we have to be in the loaded. If it's 64, then at 250 VH, it should be 3 to 32. Okay. I'm not that good at maths, but yeah, you get the point, right? So basically using the scroll fraction, we are calculating that. And now using the frame count is the total image. Now we are minusing the frame count and getting this thing. This has been generated by ChatGPT. I don't know how this works. Okay, this is pretty simple. We are now calculating the frame index based on the scroll fraction. Now our total count, the one I have already explained you the math over in the this thing. Let me just quickly get you through. So this is the x we are calculating. Now this x is actually calculated using this formula. We are actually this 42 is basically in multiplication with this. So let me just put it over here, which is the 42, which is the total width or the total frames. Now we have the scroll fraction, how much we have done and how much we have to done, and we are just multiplying that with the frame count. Frame count basically means this is the total images, how much images that we have over here. So using this, we are actually getting the exact frame that needs to be scaled based on the total height or the total scroll that we have. Now we are just now the current frame is basically the frame index, and we are just rendering it again. All right, so now our frame is done. Now let's go over to our frame and let's just draw this. Okay, there you go. And now it's already working pretty fine, as you can see over here. But if you see, if we reload it now, as you can see, it squints a little bit, right? Now we don't want that. We need to be in CSS. We have this thing called object fit, which is cover. So which basically means we don't want to shrink it, but we will just scale it according to whatever space is left. I just need that. So we'll do right now. So basically have to check. Now sometimes I wonder how much the CSS guys have helped me to, just do object fit and image. I don't even care to look at the mat, but when you have to implement that, it's it's pretty plain. Now what you have to do is we have to basically check for two cases. Basically, the first case is how if the height is basically now if the canvas is greater than if the canvas height is greater than the width, then we have to scale horizontally. And if is the other case, we have to do vice versa. Now we are getting the image that is the current image, all right. And then if image is not there, we just return over here, because if we just do images.height, we'll just get an error. So we don't want that. We'll just return if image is not loaded. Now we have to get the canvas ratio. So if that's pretty explainable, if the width is, let's say, greater than the height, this is going to be greater than 1. If not, it's going to be less than 1. And also the image ratio, right? So if the canvas ratio is greater than the image ratio, it basically means canvas is wider than the image. So we have to, first case is if the canvas is wider horizontally than the image, then we are basically going to be scaling the image based on the ratio of the width rather than the height, because height is automatically because we don't have to care about the height. If it's other case around, we basically have to care about the width rather than the other things. Now if we go back, so if it's reloaded here and reload here, now it's again all right. So we now have to draw the image over here, and rather than this, we'll just do offset X. Now let's go over to Brave, and there you go. We are basically scaling based on the canvas rather than, so if we reload now, there you go. Now it's pretty clean. It's not squinching, it's not distorting as well. Now there is one more logic based on the scroll. We are setting the transparency to 0. So if it's all the way scrolled, based on here, we are basically giving it a transparent effect. So for that, we basically use a context API, which is called save and restore. So we first save the context, which basically means whatever has happened above. This is basically a checkpoint. Okay. Now we can on restore, it basically reset back itself to the normal. So why we are doing it? Let me just give you in a second the reason. But the first thing first is we are getting the total images and minusing the frames. We are setting the global context. This is just quick math. So this also basically means based on the current frame index and the total images, we are setting a global alpha. Global alpha basically means what is the transparency or the alpha value that we have, and then we are just setting the global alpha value to 0.5. So the first things first we need to do is get the total images. So if the total image is less than, if it's at the verge of getting scrolled, which basically means if my total image minus my current frame, let's say if I have 62 images and my current frame is, let's say, at 40 or 50, it's in here, I have get a threshold value of 10. So now it should start decreasing the transparency, or it should now be getting transparent gradually. We are setting the global alpha to whatever value have based on the fraction. So if the total image minus the current, let's say if total images are 42 and the current frame index is 42, it's basically 0. So we are setting the global alpha value to 0. All right, now we are drawing the image. So what happens is this global alpha value only gets applied to this image, because context doesn't work like CSS, or the canvas doesn't work like CSS. We have saved over here. Above that, the global alpha value was 1. Now we have restored. Now here we have done some changes to global alpha value that has no effect to think of this one as an isolated code, right? The save and in between those blocks, think of it as an isolated code. Now when we restore the context, the global alpha value resets it to 1 because it hasn't changed. It never changed. all right, because we have saved whatever state that we have above the code, and then we just restored that. And in between the code, we can just change any alpha value, any background color, and all those things. It will be just applied to whatever context rendering drawing that I have been doing inside that particular save and restore in the middle of that. Now let's just save this, and if you see the moment it crosses, alright, so I just wondered why it was not working, because we are drawing the image right over here, and then we are drawing the image right over here again, which doesn't make sense because this is basically drawing first, and then on top of that this is drawing. This is getting, but as they superimpose themselves onto each other, we are basically getting this full opacity version. Now if we save, now here you can see if we go right about the threshold value, which is 10, it basically gets that. Now if we go about and let's say hit 50, if it's less than 50, then we would just get the same thing, which is, now you get the point, you get the math, you get everything. If there is anything that you didn't really understand, do let me know. It was just unitary method over here with some math.floor because we don't have decimal values for the frames. But yeah, this was it. I hope you enjoyed the video. Till then, see ya, have a good day, and keep making this type of amazing dashboard. I hope you learn something new rather than dumping 3D models and videos all over your landing page, making it damn laggy.